All right, so this says name the polynomial. In order to name the polynomial, it has to be in standard form. Is this first one in standard form? It is, because largest to smallest exponents. This is implied that it's a 1, so this would be linear. And then it has two terms, so it is binomial. Please confirm that that's correct, because it is morning and I'm not sure that my brain is working. All right, so this one, what do we do with this? Yeah, you have to FOIL or, multiply it out. You have to distribute. So this would be x squared plus 2x minus 6x minus 12. Oh, excellent. So quadratic with 4 terms? No, because we can combine like terms here. So this would be simplified x squared minus 4x minus 12. Quadratic trinomial. Okay. Next is, this isn't in standard form either. So this term has the largest exponent, so negative 3x squared. This one is next, plus 2x, and that's next, plus 7. That also looks like a quadratic trinomial, unless I've made a mistake. I don't think so. All right, looks good. All right, flashback to Algebra 1. Factor the polynomial. Now, maybe I should more specifically said factor the polynomial into, well, we'll just leave it. Factor the polynomial. All right, so I'm thinking I want 2 linear binomials because it's a quadratic, so I can go x and x. And then I need 2 numbers that multiply to 15 and add to 8. So what are the factors of 15? 1 and 15 and 3 and 5. That's it. Are any of these factor pairs, do they add to 8? 3 and 5. So 3 and 5. We have to have the signs so they multiply to positive 15 and add to positive 8. Plus plus. Nice. All right, this next one is not a trinomial and it's not a quadratic. So what we need to do is look at, are there common factors in both these terms that we can pull out? So we could pull out a 2, and here I'm going to just do this a piece at a time. So if you pulled out a 2, you'd end up with a 1 and a 4. Is that right? 2 times 1 is 2. 2 times 4 is 8. Cool. And then how about x's? How many x's could we factor out of both of these? 2, an x squared. And if we did that, we'd end up with an x squared here. And would there be any x's there? Nope. All right, so that's good. I'm going to double check this by distributing. 2x squared times x squared is 2x to the 4th. And 2x squared times 4 is 8x squared, so that's good. Next, can that be factored? Yes. I'm going to rewrite this. This is the same as x squared plus 0x plus 4. Are there 2 numbers that multiply to positive 4 and add to 0? Well, negative 2 is only one number. Negative 2 times negative 2 is positive 4. Negative 2 combined with negative 2 is negative 4. That doesn't work. Positive 2 and positive 2 multiply to 4, and it adds to 4. I don't think this can be factored. So 2x squared, x squared plus 4 is as far as we can go. Yep.
How about the formula of a squared plus b squared?
The quadratic formula?
Yeah.
We could do that. We're going to end up with, what do I want to say, an imaginary number. We're going to end up, we can't factor this without imaginary numbers. We'll learn that later. So right now, in the real numbers, we can't factor it. Okay, let's look at this one. This is a trinomial, but it's got x to the third and a leading coefficient. So we want to see if we can factor that leading coefficient out. 3, 12, and 12. Anything factor out of those? 3, and we'd be left with 1, 4, and 4. And then how about we have x3, x2, and an x. Are there any x's we can factor out? An x. So if we factor an x out of x cubed, we get x squared. If we factor an x out of x squared, we get x. And if we factor an x out of x, we just get 1. So now we have 3x times this trinomial. Can this trinomial be factored? Are there two numbers that multiply to 4 and add to 4? So x plus 2, x plus 2. There we go. Now, I am going to guess that